All right, so let's finish substitution. The big idea again. Normal, previously, that's not, okay. Previously, we would look at that and say, well, how do we calculate that integral? We couldn't do it because we didn't have any techniques for it, right?
Yeah, with that,
Um,
on the camp.
I know.
You have it at 2x.
I know. Yeah, it's 2x. The point with U substitution is that this is some function, right? And the derivative exists outside of it. So we need some sort of way to get rid of reverse the chain rule, right? That's what U substitution is. Because there's a copied function with a derivative outside. That's the chain rule. Okay, so let's look at this. Now you should, I've already given you a formula for that. Do you remember what that formula is? Okay. What's the, what? The formula, remember, that should be cosine. So the formula, the way to have the derivative out, or the fraction divide by the derivative, remember that? Because it would be the chain rule, right? For the chain rule, you would multiply by 7 out front. To counteract that one, that 7, we had to divide by the derivative. Solve this. You're basically using U substitution here. Okay. You know, I just gave you a formula instead of doing the U substitution. So I want to show you this with U substitution. This is kind of the next step. So what would I set U equal to here? Right, because I want to make this sine U. So right. Now what is then du? Seven? Is 7 in here anywhere? No, so we have to move it, right? Did we go over that yesterday? Yeah, okay. So 1, 7 is we need to okay, we've replaced this data already, correct? So let's write it out. The integral, we have sine, and we have u. Right, so that's taken care of, that's taken care of, and so is that. How do I get rid of u? Or change it to terms of u? Yeah, and all I need to replace is d theta. I don't need to replace 7 d theta. So I have to move the 7 over here. So 1/7?
So basically, you're just putting in a function that's also keeping theta and substitute.
Yeah.
Okay, that makes sense.
So now I've substituted for d theta. And it's gone. Does that make sense?
But we can also put that 1/7.
You can put it in here if you want. Just 7. Okay, what's the derivative of that? 7. So I get du is 7 times d theta. The reason I moved it over here is because there's no 7 in the original. Right? There's only a d theta left over, so that has to be the only thing over there. So I move it over to replace. So what's the final answer? 1/7. What's the integral of sine? Negative cosine. And what is u? Put it back in.
I feel it in our final answer, we have to
The integral thing?
Yeah.
What's that? Because the integral of sine is.
Oh.
Remember, what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. Then we would have the derivative of negative sine is negative cosine. Then back to sine. Okay, these are derivatives. These are integrals. Does that help? You can remember. So, memorize that. If you memorize the derivatives, the integrals backwards. All right, thanks. There's another one we can use substitution on.
What is?
E to the negative 19. Yep. So you guys are starting to become wise on picking the correct terms to substitute. So we want to leave e because we know that that integral very easily. We're going to substitute here. Right. So u is negative 19. Caleb, what's du? Did you say it? Okay, so make sure it's dt because that's what we just took the derivative of. Okay, dt's here, but there's no negative 9, right? So divide. So dt becomes du, and with a negative 1 9. Everything is good. Life is good. Admit it, Alex, you're a calculus like. Come on.
No. That feels good.
You're a Cooper. You're a super duper. How about that? I had a friend in college that wrote a song and he made that.
Yeah.
Pretty funny. I don't know if I can find it. It was about college relationships. Imagine that. He's a super duper Cooper. Okay. Anyways. We also had a song about cheese toast. So what's, yeah, we were, I was friends with a bunch of musicians and it was like. Okay, the derivative or integral of e to the u is e to the u, correct? Okay. You're starting to get the hang of this, most of you. There's still a few of you that are confused, I think. So basically, you're trying to make this a function that you can integrate. Sine u, cosine u, e to the u to the fifth, anything of that nature where you can use a simple power rule or trig function. Okay. The question is, what do you substitute? Okay. Let's do this. You're gonna do this one on your own. And I'm gonna walk around and watch you. Like a creeper.
Oh, my, cool. No, don't do that, please.
Okay, go.
Okay, so.
U is what's inside there. So it's a square of U. You're gonna eliminate the x. So set u equals x squared over 2 plus 3. Square. Yes. You're right. Calculate your product. Derivative of x squared. 2x over 2.
Oh.
3. du is x dx. No, just du. So u is this. So du. So now we have the square root is equals to a. So the x and the dx. So integral stays. What is in here? See how it's inside. So that's u. And then d. See how the x and the dx now become du. The inside is u. So write this as an exponent.
And then is it just the exact same side? And then just fill in the outside.
X squared. No, we're trying to do the X.
X is substitute, x dx became du.
You plug this whole thing back in and then it's all, yeah, I know, but I was.
Write this as u to the 1. Add 1, it's a powerful add 1 to the line.
Adding one and it just, then you get.
No, because it's up, see how it's in here? X dx is u. Those will be gone. And then all your equations. You just want it inside.
Oh, plus C.
No, put the rule. That's what that's.
You don't have any, what do you have? So then.
Make this plus 3, plus 3, plus 3, and then it gets rid of this one. And the x is gonna be gone, so you can see how it's x dx, x dx. But I think you're, okay, so this
3 would just cancel out when you're done the derivative for it.
right, that's why you want to get rid of it. If it's not in here, it needs to be zero. Okay, right?
I don't know.
Then just sort of-
I don't know, or is it?
You can change the answer. So whatever that is. Yeah. Yeah.
So I see a lot of you trying to put the square root here. The purpose of u substitution is to take the inside of something out of it. So the inside of the root is what you need. So then take the derivative. That replaces those, so they're gone. With the u. And now we can, if you want to rewrite it, remember, use the power rule. So you do the 3 halves. And then if you simplify, it's 2/3. And u was.
You can leave it like that.
I did random house.
Rid of this stretch. I think we're getting there. Now we need to talk about definite integrals.
Ooh. I don't know. I think we should just take the one for this.
All right, so. Hunter, what are you gonna choose as your U? What is U? Okay, anybody disagree? Okay. So you decided to take a week off.
Mikey?
She did too. Alex. Random. What is the derivative?
Du equals
don't hurt yourself.
Now when you're eating. I think you have to divide by three.
Oh, yeah, we only have an x squared and a dx, right? So we have to get rid of that 3. So 1/3. And now we match. So. This in red, so we have u. And we have du. What? That's not right. And 1/3, right? Question is, what do I do with those? There are 2 options.
Right.
You can change them, or you can leave them. Which do you want to do?
Which is better?
The
easiest,
Incorrect.
what happens if you don't?
No, it's fine. It's fine. So if you leave them, know that they are x values. You did not change them to you. Okay. So if we leave them, we have to make sure we know that those are x values. And now we do what we always do here. Okay, let's see integral.
Wait, no. U to the 3 halves.
Okay. No, because it's not a definite integral.
Oh.
Be careful.
Dang it.
Can I plug those in?
No.
No, I can't, because they're x's. So, rewrite this with your u inside of it now. So this is 2/3, so I get 2/9. Now what's my x cubed plus 1? And 3 halves. Now I can say it's from 0 to 2. Then in terms of x again, right?
1/3 times.
1/3 times 2/3. Copy, dot, flip. Now you can do it from here, right? Okay, so that's option 1. Leave it. Okay, fine. If you like that, have at it. Okay, option 2. We still have this. Right? How would I make those in terms of u? That's what we're looking for. Put the integrand limits like that, in terms of u.
You can solve for
On the x. So this is our substitution, right? If x is 0, u is 1. And if x is 2, u is 9. Now, I don't have to mess with that over there. This is my preferred option. It's easier. Yeah, so use your u substitution value to calculate your u integrand limits. Well, I think you're gonna see this one's faster on the tail end. So the derivative is, or the integral is still the same, right? Now you can just plug and chug. You don't have to put the x thing.
So that saves you that step.
Basically. You got this to deal with, but it's easy math. This is messier. It can be a little more complicated on the back end. It gives you the same values. Okay, so take your pick. You can either leave it and put the x's in, or you can change it all to u and just finish it. So this would be 2/9 times 9 to the 3/2 minus 2/9 times 1. 25 over 9. Square root of 9 is 3. What's 3 cubes? 27, oh, I didn't multiply, that was genius. 27 times 2 is 54 minus 2. Somebody was mumbling that. You get the same answer with the other one. It's your pick. There should be another one. You're comfortable, and we start ignoring me. No. If you're uncomfortable, here's another way to say this. Calculate the area under the graph. Ah, I told you. What does that mean? How would I write this out? Right? Okay. So I'm not keying. Kylan, pick your U value. Yep. Really? Okay. Who gets the easy question? Rita. What's the derivative? Okay. Is there a 2 in that? No, so you divide it over, right? Now I can substitute everything. And who gets the pick? Gabby, do you want to change your integer limits to u values or leave them the same? So. Okay, if x is 1, u is 2, correct? Okay, and if all right, now we have everything we need. We have the limits are now 2 to 10. We have 1 over u, and then the 1/2 has to be up. A little bit more simple than that. So u is substituted, x dx is substituted, and we're good.
If you just take the derivative of x on top, would you want to
The x and the dx become 1/2 u. We take the derivative of the bottom to get rid of the top. set up where you think so. All right, anybody? Okay, fine, I pick. Rosie. I'll give you this part. One of those memorized antiderivatives. Yeah. Okay. Evaluate. I'm gonna pull a fast one under here. No, it's not a fast one. Is this right?
Sure.
The properties of logarithms is not a correct statement. Okay, we pulled the half out, right? When you subtract two logs, the same base, you can just put them together, 10/2. Don't forget your property of logs. This will probably be a multiple choice answer, all right? One more. Let's do a trig function. Holy buckets! Holy buckets leak water, that's not very good. Yeah, I know.
Expect better jokes to be returned.
I live next to Mark Jansen.
Exactly. You live?
Pretty much. Gunner, what's the value of you? You want to pick? What's the derivative of secant squared, anybody?
Just ten.
Two secant tangent, is that in there? No, you've already covered the secant, is the derivative of secant squared. So we want to pick a different u value. Yeah, that's a much better choice. Let me write out what you said. If you pick that, which is very tempting, right? The derivative is a chain rule. Outside is 2. Then the copy the inside. And then the derivative of secant is now we've already taken this out, it's gone. Is that derivative in there?
No.
No, it's not. Okay, so we want to do it
Wait, why did we do that?
because it's u now. So, but if u's tangent, what's the derivative of that? Secant squared. Now, that's, see, that's a much cleaner substitution. Well, tangent is u
Yeah,
to the third.
oh,
So if u to the third, and then b theta b. You see how all this here, it's all gone. Now, is that a lot easier? Yeah, that's a lot easier. Do you want to change your limits or leave them? So if If it's 0, what's tan at 0? Sine over cosine. 0. Sine at 0, 0. Cosine is 1. And pi over 4. And you can finish that. Okay. I think it sounds like we're doing okay here. This usually takes people a while to master. Repetition and practice with the procedure, because it's the same procedure every time. And using some wisdom in choosing your U values. So don't expect to be perfect here the first time. Did you all get the work written down yesterday?
No.
Okay. And then I have a question. We have an option to do 5.7 tomorrow, or we can do it Tuesday. Next week, we would do position velocity, acceleration, speed activity. So we can do that tomorrow or Tuesday. We only have 5.7 and 5.8. Next Thursday is your review, and then a test Friday.
We should do 5.7 tomorrow too.
Up to you.
I agree with that.
You okay with that? I thought maybe it's been kind of it's been a pretty intense week on stuff, so maybe you'd want to do that. Okay. Is any other votes? It's like 2 votes for tomorrow. The loudmouths voice their opinions. That's what we do. What? Is that what they say? It is.
Like voting, like say like if you don't vote, you're voting for the other person.
Yeah.
I don't know if I agree with that statement. Okay, we'll grade that tomorrow.
I mean,
It is though.
I am busy calculators.
You don't have to fill it.
Up to 6 now.
What if you, without her death, you can't speak?
That's not how it is though.
You're still her saying.
Yeah, that's not your choice.
What if your dad, you can't talk? And you're like, okay. Yeah. You're thinking of like sensual.
You have gone here. Yeah, we did. And now it's fun.
That she can't.
With my friends. None of them are.